Right.
And here we go, solving log equations. Well, we're doing some graphing of them first as well, I guess. So this first one says, the graph of the function is given, use the horizontal line test to determine whether it's one-to-one. So the horizontal line test is basically, remember the vertical line test, if you go left to right, that means it's a function, as long as you don't touch more than one place. Well, if you do the same thing from the bottom to the top, it will tell you if the function is one-to-one, which would mean that the function has an inverse function. That's what that does for you.
Yeah.
So you can see that this one is one-to-one because I'm never going to touch it twice. This one is one-to-one because I'm not going to touch it twice. And this one is not one-to-one because I can touch it twice. So this one does not have an inverse that is a function. Whereas these ones do have inverse functions.
Yeah.
Got it?
Yes.
All right. This next one says solve each equation, verify the solution using your log base 4 of x plus 2 equals log base 4 of 8. Is that what that says?
Yeah.
Okay, so you can just basically say, well, this must equal this, right? Technically what you're doing is you're exponentiating both sides. You're doing this,
Yeah.
which means x plus 2 equals 8, which means x equals 6, and then check to make sure it works by plugging it in, and you'll see it does. So for number 1, x equaled 6. For number 4, you have, I'm going to go down. For number 4, it says -2 log base 4 of x equals log base 4 of 9. So the first thing you're going to do is rewrite this as log base 4 of x to the -2 using properties of logs, right? Equals log base 4 of 9. Now again, we can say x to the -2 equals 9. Well, remember 9 is just 3 squared. You might want to write it like that. So now we're going to take the -1/2 power of both sides. Got it? Because that will take care of that. That will turn that into just x. And that just equals 3 to the -1, which is 1/3. And if you want to check it, you can type in log base 4, -2 log base 4. Did they say to check with a graphing utility? Okay,
yes,
so
it does.
here's how you would do that. In your graphing utility, you would write, type in -2, now log base 4 of x. -2 log base 4 of x. So there's one of my equations. And the other equation is log base 4 of 9, which is just a number, right? 4 to what power equals 9? You understand that?
Yeah.
So log base 4 of 9. And now if I graph them both on the same graph, I can see where they intersect.
Yeah.
And on your graphing calculator, you'll be able to find the intersection point. But there, I happen to tap it correctly. And the answer, look at that, x equals 1/3.
Yeah.
Which is what we thought. Okay, so number 2. Log base 5. So again, this must equal this, right?
Yeah.
Understand that? So basically we can solve that in our head. Subtract 3 from both sides, you get 0. X equals 0. Number 5, again, similar to number 4. For number 5, I'm going to say that, so I'll write it down here. I'm going to convert each of these using the exponent rule, bringing that 2 up to the front and bringing the 3 up to the front. You follow what I'm doing here?
Yeah.
And this means that x squared, exponentiating both sides to the base 5, x squared equals 4 to the 3rd. And remember, 4 is just like 2 squared, right? So I'm going to write, instead I'm going to write 2 to the 6th. You follow that?
Yeah.
And then I'm going to take the square root of the 1/2 power of both sides. And the 1/2 power is going to be 3.
Yeah.
X equals 2 to the third, which is 8. Okay, good.
Yeah.
All right, the next one, same deal. I'm going to do that same thing. Log base 3 of x to the 1/2 equals log base 3 of 2 squared, which means x to the 1/2 equals 4, right?
Yeah.
Which means x equals 16, squaring both sides.
Yeah.
And again, always check your answers, plug them in to make sure that you did them right, or to make sure there's not an extraneous solution. That's another thing. Make sure you're not
Yeah.
taking the log of a negative number, which I'm not in any of those. So this last one, you tell me what to do for this last one.
You have to first. So for negative log base 2 of 27,
Mm-hmm.
you could take out the I don't know how to draw it on here, but I'm not able to do that. Okay. You would have to take 27 is 3 to the power of 3, so you could just pull the 3 out. It would
Okay.
become negative log 3 base 2 of 3.
Okay, so that you're talking about on the right side,
Yeah.
negative log base 2, you're saying,
Yeah,
of
of
3 cubed.
3. Yeah.
Okay. And should I still keep this 3 over here like this?
You'd move the 3 on the right side. The 3 that's an exponent, you move that to the outside, so it's like negative 3 times log base 2 of 3.
Oh, good. Okay. Yep, you can do that. And then
And
how
then
about on the left side?
you can cancel out the negative 3 and the 3. Yeah, you
Okay.
can cancel out the 2 3s.
Okay. Got it. Cancel them out. I still have a negative 1 though, right?
Yeah, so it's negative log base 2 of 3 equals log base 2 of x.
Okay. Now what?
Well, you would just take that and put it to the, oh, that's what I could have done. You would just take that and put 3 to the power of negative 1.
That's right. Good.
That would be log 2 times 1/3.
Okay. So what does x equal?
X equals 1/3.
Good. So x equals 1/3. Yep. Good. Good job. All right. This next one, this is a different set of problems. Which ones do you want me to do?
Um, the odd ones are the ones that we were supposed to do for like the homework. So
Okay. So
and maybe
you
try.
want me to do the odds or you want me to do the evens?
I want to try 11
Okay. So
because
for
it has
11,
natural log.
right. So the natural log of x, which just means log base e, ln of x plus 2 equals 4. So what we're going to have to do is combine these together with the property that says what? It says that the
That
ln of x times, it says that basically you can multiply them together,
yeah,
right? So now I'm going to convert this to an exponential. This means, remember, this is log base e. So
yeah,
basically, this is the same as saying that x squared plus 2x equals e to the 4th.
yeah,
You understand how I got there?
yeah,
Using the equivalence. So now I'm going to get x squared plus 2x minus e to the 4th equals 0.
yeah,
And now I just use the quadratic formula to solve for x. So x equals negative b plus or minus the square root of b squared minus 4a, which is 1, c, which is negative e to the 4th, all over 2a. Whoops, 2a is just 2. And then just plug that into your calculator and get a decimal approximation for it. So we have negative 2 plus the square root of 4 minus, actually it's going to be 4 plus, right? 4 plus, because a negative times a negative is a positive. So 4 plus 4 times e to the 4th. Got it? -2 plus, I'm looking back at my -2 plus, I'll also do the minus 4 plus 4 times e to the 4th divided by 2.
Yeah.
And so there's one of your answers. So equals approximately, so you use a squiggly equal 6.46. The square root of 4 plus divided by 2. So -8.46. Those are your two answers.
Yeah.
Now you want to know how you can, have I explained to you how you can check that answer?
You just substitute it back in, or
Yeah, do you know how to do it on your calculator with the store button?
no?
So the store, what I just hit was store, which is the button above the question mark on the lower left-hand corner there, the STO with an arrow. I'm storing that answer for X. So every time I type an X in, it's going to substitute that in. So there's double of X. Got it?
Yeah.
So now if I just type in ln, if I type in ln, I'm literally typing number 11 on that left side, ln of X plus ln of X plus 2. And I hit enter, I should get what? If I did it correctly, what should I get? When I plug that back into there, what should I get?
You should get 6.46.
Nope. Look at what the
No,
question
wait,
says.
4. Sorry.
Yeah, I should get 4. Oh, and
This
it's
is no
saying
real
no real
answer.
answer. Oh, that's because that one, I'm glad I checked that. That's because that one is a negative number. And can I take the log of a negative?
Oh no.
So that's called an extraneous solution. So that one didn't work. So now let's try a different one. Let's let x equal the other one. So 6.46, storing it for x, and now typing in ln of x plus ln of x plus 2, and whoops, ln of x plus 2, and what should I get?
You should get 6.46. Oh, wait, you should get 4. I mean, sorry.
Good. And actually, it's probably not going to be exactly 4, right? Because I
Yeah.
rounded it, but I should get pretty darn close to 4.
Yeah.
Okay, so 15 says 3 to the 2x plus 3 to the x plus 1 minus 4 equals 0. Kind of tricky. So here's what you're going to do for this one. You're going to rewrite this as plus 3 times 3 to the x minus 4 equals 0.
Yeah.
And that way you can let u equal 3 to the x. You understand?
Yeah.
So this really is just u squared plus 3u minus 4 equals 0, which factors into u plus 4 and u minus 1, which means u equals -4 or u equals 1. Got it?
Yeah.
And remember, u was 3 to the x, so 3 to the x equals -4, or 3 to the x equals 1. And can 3 to the x ever equal -4?
No.
Can you plug in anything up here that will give you a negative number?
No.
No. So that doesn't have a solution. And how about this one? What's the solution for that?
0.
X equals 0. If you plug it back in, you'll see, oh yeah, duh. That's 1. That's 3. And minus 4 is 0. 1 plus 3 minus 4 is 0. So that worked out.
Yeah.
How about for these 4? Give me one from there to do. You pick any one of them. Can you see how 16 is very similar to 15?
Yeah. We can try 13.
Okay.
It's pretty similar to 15 and 16,
Yeah, but
but
it's
I want
very
to try.
similar.
I'd like to try
Yeah,
it
you try.
anyway.
You tell me. You give it a shot. Do you have a way to write on this by chance or no?
I do not believe I do. Can I just,
Okay,
is
well
it possible?
you tell me what to write and I'll write it. How about that?
Right.
Here's the problem. 2x 2 to the 2x plus 2 to the x minus 12 equals 0. Tell me what to do first. 2 to the power of 2x. You want me to write that?
You can kind of, okay, so you can use two, because you can use, never mind, that wouldn't work. I was
Look at
thinking
what I
something,
did for the last. Look what I did for the last one.
yeah, that's what I
What
was
did I do?
thinking. You kind of, you were able to kind of distribute it out, or you let, 3 to the x be a certain value. You let 3 to the x
That's
be
right.
u. So 2 to the power of x can be u, and the first one can
There we
be,
go.
the first one would be 2u, or no,
Nope,
would
it
it be,
wouldn't be 2u. It'd be u squared
yeah, u squared, that's correct. It would be u
plus.
squared plus u.
Mhm,
Oh, would it actually, would it
minus.
be u? Oh, sorry, would it actually be u squared? Because if it was u squared, wouldn't it be 4 to the power of 2x?
Nope, because this is the same as 2 to the x squared.
Ah, yeah, that works. Okay.
You understand what we're
Yeah,
doing
now
there?
I understand. Now I understand.
Yeah,
Okay, so now you can kind of distribute it out. So
factor it out, you mean?
yeah, so you can do u to the u plus 4, u minus 3.
Good. Then what?
Then u either equals -4 or u equals -3, or u equals 3.
Mhm.
And
Then
so
what?
u equals 3 would be the only answer that's viable.
Good. So let's write 2 to the x, right? Okay. And so what does x equal?
So x equals, I'm not sure.
So this is where you would use your, do they want you to write as a decimal approximation?
Yeah,
Yes.
yes.
Okay. So this is where you can use your, you can take the log of both sides and then the x comes down to the front.
Yeah.
So x times log 2 equals log 3, which means x equals log 3 over log 2.
All right.
That's log base 10. So log 3 divided by log 2, those are just numbers. And that equals 1.58 approximately. And again, to check, let's store that for x. And now let's type in 2 raised to the 2x plus 2 raised to the x minus 12. And what should I get?
You should get 0. You should
Let's
get
see.
0.
Now, that number doesn't look like 0,
Yeah.
but is it? What does that mean? Do you know what that
Oh, yeah.
means in your?
That means it's a really small number because of
Yeah,
significant figures.
that's right. So that means it's what that basically means when I plug that in, that's negative 0.0000 14 zeros and then 177.
Oh, okay. Yeah.
You understand? So the total
Yeah.
number of zeros here was 14. That's really close to 0. Your calculator is smart though, and it actually found the exact answer. And what it used was not the exact number because it approximated it at some point, right?
Yeah.
There's a rounding error in your calculator. So you have to be smarter than your calculator when you're doing those problems. Okay, good. Do you want me
Yeah.
to make a copy of this slide and do some more questions that are on it, or was that enough for this?
That's actually, there's not any more questions I've put on there, so these are just everything that I have so far. So yeah,
Oh, okay.
I guess
So
make a
let
copy.
me duplicate that. Let me duplicate that, and all right, let's do number 10. So the log base 4 of x plus the log base 4 of x minus 3 equals 1. Tell me the first step.
The first step is you can basically multiply it out. So it becomes log base 4 of x squared minus 3x.
Good. So you're combining them, right? You're condensing is what that's called. Good.
Yeah.
Log base 4 of x squared minus 3x equals 1. Now what?
I'm not exactly sure.
So this is where you use the
Change of base rule?
no, it's called the equivalence. This is super important. So the equivalence says this: if you have a log base b of x equals y, that's the equivalent thing as saying b to the y equals x. Look at what
So
I do. I go b to the
it would be
y
4
equals x.
4 to the power of 1 equals x squared minus 3x.
You got it.
So it would just be
Now what?
4 equals x squared minus 3x. And
Good.
then you
Now
could
what do I do?
subtract the 4. It becomes x
Mhm.
squared minus 3x minus 4 equals 0.
Good. Now what?
Now you can distribute it out, so it becomes
By the way, that's not called distributing, it's called factoring.
factoring. Yeah, that's what I meant.
It's actually undistributing. You're
Yeah,
unfoiling it. Yeah,
that's what I meant to say.
I know you did. I just want to make sure you know that.
Yeah, it would be x. It would be x plus 1, x minus 4,
Good. So x equals,
negative 1, or x equals 4.
okay. Now check for extraneous solutions.
Negative 1 is an extraneous solution.
Correct. So your only answer is x equals 4. And you can plug it in just to check, and we can actually see that that works because this is 1 and this is 0. Let's try 14.
Yeah,
All right. You tell me what to do.
3 to the power of 2x plus 3 to the power of x minus 2 equals 0. And so now we can set 3 to the power of 2x can be 3 to the power of x can be u. And so
Good.
the first one is u squared.
Good.
U squared plus u minus 2 equals 0.
Perfect.
And then you just factor it out. So it becomes u minus 1. Oh, sorry, u minus 1, u plus 2. Yeah.
Good.
So the answers are u equals 1 and u equals negative 2.
Good. Which
And you can,
means 3 to the x equals 1. 3 to the x equals negative 2.
yeah. And then u equals negative 2 is extraneous. So the answer is
Good.
1. 3 to the power of x equals 1. And then x
Which
equals
means
0. X equals 0.
good. Perfect. And you can plug it in and check, and you'll see that you did it right.
Yeah.
Good. All right.
I'll do 9. I'll
Okay.
do
So
9.
tell me what to do first.
First, you would, oh, it's not the change of base. Yeah, you can multiply it out. So it'd be log of x squared plus 15x equals 2. And then that would
Mm-hmm.
basically be log of 10. I mean, not log. It would be 10 to the power of 2 equals x squared plus 15x.
Good.
That's basically 100 equals 15x. And you can subtract 100 from both sides. It becomes 100 equals 0.
Good.
So if you were to factor this, it would be x plus 20, x minus 5.
Good job. By the way, do you know that it doesn't have to factor?
Oh, really?
Yeah. You know that you could still have a solution even if this was like, I don't know, 90.
Oh, yeah, yeah. You could use the quadratic formula.
Yes, exactly. So I just want to point it out. These answers are all working out nicely, but they don't have to work out nicely. They could be irrational, crazy numbers, right? I just want to point that out to you so you don't get if you ever get one that doesn't work out so nicely, you don't have to freak out. It's not a big deal. It's just not a rational number, and that's okay. So what does x equal?
X equals 20.
Sorry,
So
I'm getting ahead of it.
X can
I'm
only
getting ahead of
equal
you.
5. X can
That's right.
only 5.
And the reason is because of what?
Because you can't have the log of a negative number.
That's right. That's the only reason. So 5 it is, and that's probably the right answer. But we can check it. We can check it by plugging 5 in for x, storing it for x, and then typing in log of x plus log of x plus 15. Log of x plus log of x plus 15, and we should get 2 for the answer. A little bit of a trick question because you can't do that. Does not exist. It's not a real number. This one I'm guessing we can do somehow.
Yeah.
Well, you can see that all these things are powers, right? So
Yeah.
this is a power of 3. This is a power of 2. That's what, 2 to the 5th. This is 3 cubed. This is 2 to the negative 1 or negative 2. This is 3 squared. So you can multiply, you can distribute this into there. Let me see how I can rewrite log base. What do the directions say for this again exactly?
The directions, I guess it just says to evaluate them. Well, not like evaluate, I mean solve. Just not solve, I'm sorry. I guess just simplify them.
No, evaluate could be right. Find the value of.
I'm not necessarily sure what it says. It just says,
Or simplify.
it doesn't really say anything. Let me see again, just to make sure.
So for this one, it would be log.
Yeah, no, it doesn't say solve. There's other ones on the pages that say solve, but these ones don't. So I guess it's just simplify.
Let's do log base 10 for both of them. So that would be log of 2 to the 5th over log of 3 cubed plus log of 2 to the negative 2 over log of 3 cubed times log of 3 squared over log of 2.
Yeah.
Okay, so what's going to happen when I distribute this is I can then cancel out things. That's what's going to happen.
Yeah.
So when I distribute this there, so we'll have, and actually now you can take the 5, all those exponents down to the front, right? Using that one property. Those all come down to the front. So really what I have is 5 log of 2 over 3 log of 3 times 2 log of 3 over log of 2.
Yeah.
I distribute that in, right? We'll clean that up in a second. Plus negative 2 log of 2 over 3 log of 3 times 2 log of 3 over log of 2. And now I can cancel out factors. That's a factor that cancels. That's a factor that cancels. That and that cancel. This and this cancel. So I just get 10 thirds minus 4 thirds, which equals 6 thirds, which equals 2. The whole thing just equaled 2. I'm again perplexed by that number 3 because you can't even do that. Like right from the onset, you can see that doesn't simplify.
Yeah. I'm wondering if, never mind, that wouldn't work. Oh, maybe they wanted us to write it as 1/8, no, not 1/2 to the power of 3. 1/2 to the power of -3.
But that's not what it is.
You can't have a log of a negative number, yeah.
That's, yeah. That, what you're saying is kind of what I was thinking too, perhaps. But it's just not, yeah, but that's not what it is. So any other challenging ones like that?
Um,
Or anything that's coming up maybe?
yeah, sure. I also kind of wanted to go over inverse functions.
Yeah, I was just going to suggest that. We could do some inverse function ones. Did you have any like that?
Yes, I do.
Okay, so to do these, what we're going to do first is switch x and y. So I write x equals 2 over 3 plus y. And now I solve for y. So multiply both sides by 3 plus y. Now I'm trying to solve for y. So I distribute the x in. And now I isolate the y. So I subtract 3x from both sides. And now I divide both sides by x. And there's your inverse function.
Yeah,
Okay. So for the next one over to the right, I would
yeah,
interchange x and y. Now this one's going to be trickier because there's two x's over here, right? So now there's two y's
yeah,
over here. So to isolate this, I'm gonna have to, I'm gonna have to first multiply that over and then distribute. And now move the x's together and the y's together.
yeah,
So I'll move the y's to the left side. So adding 3y and the x's to the right side. So adding 2x. Now I factor out a y. And now I divide. Got it?
yeah,
Okay, for this last one, I'm going to interchange x and y. Multiply both sides by y, square root of y. Divide both sides by 4 because I'm trying to solve for y. Square both sides. Now there's a caveat with this one. Because when you just squared both sides, you turned it into a bigger function than it was originally. So you have to write that the
yeah.
let me think, how do you write this? The range of the domain of the original function
Yeah.
was x had to be greater than or equal to 0. So basically the range is y has to be great. Well, do you even have to write that? Y is greater than or equal to 0. Maybe you don't have to worry about that because it's going to be greater than or equal to 0 because x is never going to be negative in this case. Sorry, x can be negative, but y itself is never going to be negative. So let's see. What am I thinking about?
Yeah.
I feel like there's something else you have to do to this one. Let's take a look at the graphs just to see. If I graphed 4 divided by the square root of x, the graph is going to look like that. Okay, so it's 1-to-1. It's a 1-to-1 function, right? I believe. Let's zoom out a lot. Make sure it's not doing something else. Yeah, it's got a vertical asymptote and a horizontal asymptote. So the inverse of that would be, let's make sure that the inverse is correct. The inverse, let's see if I plugged in this equation. Whoops, why did I do that? 16 divided by x squared graph. Here, let's only look at that.
Yeah.
Let's clear this one. Yeah, see, do you see the problem? It shouldn't be also going to the left.
Yeah.
It should only be the one going to the right. So I think what we have to do is limit the, yeah, I think we have to limit the domain.
Yeah.
We have to say that the domain is from 0 to infinity. Yeah, and again, the reason is because if you look at this original graph, the range is going to be what?
Yeah.
The range, it's never going to be negative, right?
Yeah.
And when you squared both sides here, when you introduced the square, anytime you square something or raise something to an even power, you're basically introducing extraneous solutions into your solution set, and you have to account for that. So I believe that you should write this to do that correctly, because technically that is what the domain should not be negative. You shouldn't be plugging negative numbers in. Okay.
Okay. Okay.
And the reason isn't because here you weren't plugging negative. The reason is because the range of this was only positive numbers.
Yeah.
That's the reason. So the domain, you should not be plugging negative numbers in, because that did not exist in the original function.
All right.
I would check the answer key for this one to see what they wrote. Do you have it by
Oh,
chance?
yes, I do have the answer key.
Did they say anything like that? Did they put like a domain restriction on that?
It says the range and domain, domain and range for both functions are 0 and infinity.
Right. So they have to actually, but what did they write the answer for here? I'm assuming they wrote something. Was the answer 16 over x squared? Where
Uh,
did it say like where x is greater than?
yes, it does. That's exactly
Okay.
what it says.